Okay, so this is mostly for year 12 physics. This is to do with what a closed system is. This train, I want you to consider as a closed system. You have to imagine that the train track itself is frictionless, so that has nothing to do with the experiment. Now, at the moment they have zero momentum. That means also the system has zero momentum. If they're in a slightly different position and they were tensioned like this, they have zero momentum at the start, and if I release them, watch what happens. Both move towards each other. Now, because the momentum has to be zero of the system, whatever momentum this guy got going that way, is the same as the momentum of this one going that way. Which means that when they add up, because momentum is a vector quantity, the right-hand momentum would be considered positive, let's say it's 10, and the left-hand momentum towards me would be considered a negative. So when you do plus 10, minus 10, you get 0. Now, this is fairly easy to understand at the moment because they've got the same number of carriages. So you can see they are actually going pretty well at the same speed initially. If I change the number of carriages, so if I take him off there and then do it again, then we still have zero momentum. So what happens? You can see this one goes a lot faster because it still has to have the same momentum which this one had. But this one's got more mass. I can make it even worse because I could put this with 3 carriages to this one. And the second one of these springs has come undone. So if I put 3 carriages on here and now do the same again, you see this one goes really fast. That's because it's got a third of the mass of this one. So one of the things we can say about momentum in a closed system is that it is a fixed quantity. That means whatever momentum we had to start with has to be the same momentum that we end with. Now there's a whole load of board work I'm going to do on this for you, but this is the demonstration showing you how it works. This thing here which we would be talking about here could be considered a collision of some form. Alright, so there's a whole lot of board work about collisions, and there is the awesome exam question which you're going to have to answer about the moose. Alright, you can look forward to that.